Hello, everybody. So now we start our afternoon session. Can you get back to your seat? And we're going to start with the E3SM post-processing with Ryan Forsyth and Chris Gorman.
Okay, let's get started. So this is on E3SM post-processing. I'm Ryan Forsyth. I use him pronouns. So we're gonna talk, if I can, yes, very good. Be nice to go away, but okay. So basically what we're talking about here is after running the model, what do you need to do? So if you've looked at the E3SM documentation, we have a step-by-step guide. We're going to be covering the post-processing steps and the long-term archiving steps. So we're going to briefly touch on short-term archiving, but the tools we are really going to be using are Zippy and Zstash. Okay, I guess I have to be pretty close to this. All right, okay. So yeah, briefly touching on short-term archiving, by default, E3SM will store all output files under the simulations directory and a run directory. But for long simulations, you could end up producing tons of files, like hundreds of thousands of files. That can really slow things down. Even LS will crawl. So what we have is a short-term archiving tool that will archive files neatly by components. So here we have a table organizing by which components are atmospheric, land, whatever. There's a directory and they each have a file naming pattern. So I'm not going to spend too much time on the short-term archiving, but this just sets things up nicely for the post-processing. So with that, we'll go into Zippy. So Zippy is the post-processing coordination tool. So Zippy sort of coordinates everything else you've been hearing about on this tutorial, all these other post-processing tools. I'm sure it might be overwhelming. Zippy's here to just run it all for you. You just need to run a single configuration file and it handles everything. The packages themselves, as I mentioned, have been covered elsewhere in the tutorial, but Zippy will run them. You can even plug in, there's a plugin feature for other features that aren't included in Zippy. So ChemDag, for example, uses that. But these on the table are the packages that are included with Zippy. And there's a roughly but not exact one-to-one correspondence between task and underlying packages. So there's the Climo task, which uses the NCO package to generate climatologies. There's the TS task, which uses the time series, the NCO package to generate time series. And optionally, there's the E3SM to CMIP package, which can format the data in CMIP conventions. Then there's the TC analysis task, which is a collection of scripts to do tropical cyclone analysis. Then we have diagnostic packages. There's E3SM diags and MPAS analysis and ILAM, which sort of cover different components for which diagnostics to analyze. And then global time series is a collection of built-in scripts built into Zippy. So that's not really a package that Zippy's calling, but it's really good for providing overview plots of how the model's behaving at global level. Also, there's hemispheric averaging as well. So moving on to run Zippy, again, it's one configuration file that has everything you need to know. It's hierarchical, so with a few exceptions, parameters are defined at one level, and then you can override parameters. So there's very little duplication involved. Tasks can have subtasks. So for example, you might be running climatology for atmosphere and land, or monthly and diurnal. So again, it reduces duplication on the configuration file. Each task and subtask directs Zippy which jobs to create. And that's mainly determined by the years parameter. So if you're trying to process 200 years of data, there's a couple ways you could increment. You could slice that up, right? You could do 20 10-year increments. You could do 10 20-year increments. So you just tell Zippy what increments you want, and it will launch the job. So you don't have to launch 20 10-year jobs. If you've configured it in the configuration file, Zippy will launch all those automatically. And another nice thing about Zippy is if you rerun it, only the jobs that have failed will be rerun. So you don't have to think, oh, which ones do I need to rerun? Zippy knows what to rerun. Each job has a log file and a status file to look at. We'll talk about that more later. And some tasks are dependent on the output of other tasks. So for example, these diagnostic packages, right? We need to have climatologies and time series generated to be able to run those analyses. So Zippy will determine, oh, we need this task to complete before we can do this task. You don't have to worry about that. Zippy puts all that out of your mind, and it runs it tells the scheduler which jobs to launch, gives the scheduler, which is Slurm in our case, to launch certain jobs based on which jobs have finished already. Lastly, Zippy is included in the E3SM unified environment, which I think you all have been familiarized with so far, but it is one of the packages in there, but you actually have the option to use whatever environment you want. So this really comes in handy if you're using the latest version of a package, which maybe isn't in unified yet. So you're able to customize Zippy really quite extensively. So now sort of switching gears to long-term archiving, the other package I'm going to be talking about is CStash. And this is what you really want to use if it's a valuable simulation. You want to long-term archive it on the high-performance storage system here at NERSC. And it has a few key features. It has tar files, which you can specify for a maximum size. There's also a default. The tar files are first created locally and then transferred to HPS if that's what you want. Checksums are used throughout Zippy and they're computed on the fly for create and extract to make sure that both individual files and tar files haven't lost any data or got corrupted in any way. So checksums make sure that we're archiving correctly. And we use a SQLite3 index database to track everything. And again, that also enables faster retrieval and file integrity, again, verified by checksums. Another really neat feature that we'll discuss briefly is using Globus to transfer to NERSC HPSS. It's a little less useful right here because we're already at NERSC, but you might not be running on a machine that has HPSS, and you can use the Globus tool to transfer to NERSC directly through CStash. You don't have to do a separate step for that. So for CStash, there's a few commands you have, but they're pretty basic, right? It's what you would expect. Create an archive, update the archive, verify that it was uploaded correctly, list the contents, and extract the archive. So we'll go through some demos for Zippy and CStash. So I'll click on these in a sec, and then we'll have problem sets for the practicum. So what I'm going to do now is hopefully I can switch to GitHub and run through some demos together, and then we'll work. I'll give you all time to work on problem sets. So let me see if this works. Okay. Yes. Minimize. It's not big enough, so I'll see. Okay. So basically for this demo, I wanted to make sure that I ran everything correctly. So I ran all the commands before and put the output in this markdown file. You can access this file. These links are in the slides that are on the public agenda. And you can run through it yourself. And I would highly recommend trying to run through it yourself with the commands. You can do that with me or later. But I'm just going to be going through this markdown here. So first we need to load the unified environment. So 1.10.0 is the current latest version. And because it's the latest version, that means you can just run the load latest unified script. And now I'm just going to briefly touch on short-term archiving. So these are the commands to create that. There's a case scripts directory, and then in there's a short-term archiving tool for your simulation. And then that will output the archive data into the archive subdirectory. The simulation we're using today for this demo already has that done. It's been short-term archived, so I've put the path to that here. In addition to that, there's a few files we need to run for MPass analysis. The ocean and sea ice restart files, input files, and the streams data. So that's all I'm going to say on short-term archiving for now, but there's more information in the docs. So now we're going to jump to the Zippy configuration file. So this is where the real meat is. Everything about Zippy is in the configuration file. So we're going to hop over there. Maybe I should expand. Okay. So one thing that's really important is on the Zippy docs, there's a parameters page, and that lists all the parameters in Zippy. And if you have any questions about how to use it, they're all described there. It links to a default.ini or any file, which has the default values for all the parameters. So you'll see more as we go through this configuration file, but it's extremely hierarchical. So subtask, inherit, from task, which inherit from this default section here, which inherit from the default.ini file, which is sort of the global defaults. This default section here is your own default in the configuration. Let's see, okay, mention that. So again, I'm just going to run through this here, but if you want to try to run this yourself, you're going to need to make sure to update pass to have your username, not mine. Also, we have some nice tools here today. We have a reservation to actually get nurse nodes, so you need to change the account and reservation to match. I believe that's ntrain 6 for account and E3SM day 3 for today. So going through, so again, this default section sort of defines the stuff you want to apply throughout the configuration file. There's the case, so for us, it's going to be this extended output.v3.llr.historical0101. ProMeter has a couple possible constraints, CPU and GPU. We're going to be using CPU as our constraint. And then for input, this is really important. This is the input to Zippy, so it's the output from your simulation. So you want to put the output of your simulation as the input to Zippy here in this parameter. And then the output is where Zippy's output will go. So what's really nice about this is you might notice you probably don't have write permissions to where that simulation output was, but we can use it as input and then output the Zippy output in our own directory. So it doesn't matter that we don't have write permissions to that directory. We can analyze someone else's simulation, no problem. So we're going to do that here today by putting our output in a path we have access to. And then I just have a brief note on the quality of service. This is useful, for example, if you're submitting 5 or fewer jobs that run in under 30 minutes. We're not doing that today, but if you just have a few jobs to run, the debug QoS is really useful. And you can read more about the policies in the nurse documentation I have linked there. Okay, so going down, wall time is defined as 2 hours in the default.ini file, but I'm running a really short example today, so I've set the wall time as 30 minutes. So this means that throughout the file, the wall time for all the jobs is going to be set to 30 minutes, even though the original default was 2 hours. The www file or path, this is what links to the web server path. So if you, all these diagnostic tools I mentioned, E3SM diags, MPass analysis, ILAM, global time series, those produce visual output. So where can you see those? That's going to be the web server path attached to this www. And Zippy will include the case here. Okay. So I'm just going through this really high level, I'm not trying to repeat myself here. I just want to give you an overview because it can be sort of overwhelming at first. So I really wanted to sort of walk you all through it. So this is the first task, really, the climo task, and this defines what climatologies we want to generate. One thing that's important is to set active to true. This is really nice because if you don't want to run a certain set of jobs, you can set it to false. You don't need to delete it or uncomment it. You can just run what you need to run. So the true tells Zippy that we want to run this section. And then years. So I mentioned you can increment differently. So this is 2000 to 2004 in 2-year increments. So that means for each of the subtasks for Climo, we're going to launch 2 jobs, 2000 to 2001 and 2002 to 2003. And we have 3 subtasks. So this is actually going to launch 6 jobs. So we've launched 6 jobs just with this bit of configuration file. So our first subtask here is to do a monthly atmospheric climatology. We've set the mapping file. And another cool thing I want to point out is if you set variables to be the empty string, it will process all variables. So that's something that NCO will do. It will generate everything for you, all the available variables. This next subtask is the diurnal climatology. So it's 8 times per day. So it's every 3 hours. So we've set the frequency to be that. The input file needs to change. It's not the H0 anymore. For this simulation, it needs to be the H3 files. That's the diurnal data for the simulation. So you really need to pay attention to what are your input files and input directories. Mapping file. Here we're just going to do total precipitation for diurnal. So this, we don't really care about all the variables. We're just going to run on one variable here. And then for the third subtask, we have the land climatology. So notice the input file is again H0, but now it's ELM because now we want the land model. This is something that's really important to check. It's easy to get tripped up and think, oh, why can't I find my variables? And it turns out that, well, you were looking for land variables in the atmosphere. So make sure to check that. You'll notice the subdirectories also changed to be land. I'm going to walk through time series a little faster since it's pretty similar to Climo, but you can see that we launch a number of jobs. And then we have a few overriding subtasks. So for most of the years, most of the subtasks, we're still doing this 2-year increment, but for the global climatologies, we're going to do 5-year increments. So that will override. We're doing it on 10 years, so in this case, it's still producing 2 jobs. So we have 5 subtasks, each with 2 year slices. So we're producing 10 time series jobs out of this. So for the atmosphere monthly time series, one thing I want to point out is this TS format is set to CMIP. This is what tells us to use the E3SM to CMIP package to generate the output in the CMIP format. Going on, we have the daily time series, the global time series. Notice the mapping file is global because we want global data. And it's pretty similar for land and land's global. We need to make sure the input files and subdirectories are right. Also make sure to not include spaces in your variable list. You want just the variable comma variable. So we're moving into the diagnostic tool. So this is probably the more fun part, right? This is the visual output. You can look at all the plots of your data. So going forward, we have grids, E3SM diags. If you, I believe the presentation was yesterday, you probably saw all the different sets that are possible. You can do so much analysis with E3SM diags. So you can set which sets you want specifically here. Oh, this is set up differently than my Mac. Okay. So we've put quite a few sets here that we want to run. The short name is useful because sometimes if the case name is too long, it will sort of make the plots look messy. So the short name makes the plots look nicer. The TS num years is the number of years that we were incrementing in the time series task. So E3SM diags really needs to know that. So we've provided that here. And then we're going to run model versus observation. And what we're going to do is mostly inherit from what we've already set in E3SM diags, but I've also put a few things for the climo-diurnal because we're running the diurnal cycle climatology diagnostic. So we've set the frequency for that, diurnal 8 times a day, and then the subsection. I know I wrote a lot here, but basically the gist of it is you can customize what the subsection names are. So you need to tell Zippy, oh, this is the subsection that we need to depend on. It will figure it out if it's not, if it's sort of expected, but if it's something different, for example, the way this is with the diurnal, it's nice to set it explicitly to tell Zippy what it should refer to. And there's,
Sorry, what do you mean by subsection?
yeah, the subtask. So if we go back up here, so time series, yeah, I guess I should have said subtask. Yeah, sorry. Yeah, so TS was a task, and then the atmosphere monthly is a subtask of the time series. Yeah, sorry about that. Let's see, where was I? And then we're doing a comparison with observations. So we have the start year and final years for the reference. And then that will generate the E3SM diags. And then I'm just going to go quickly through the other diagnostic tools here. Another one we have is empath analysis. So we've set a number of parameters for that. Empath analysis takes a little longer, so we're going to run 2 hours. We also did that for E3SM diags, actually. And then going forward, the global time series. There's 8 standard plots that get generated. You can actually customize it whatever you want, but there's a typical 8 that we display. So we have the climo years that should match empath analysis, the same for TS and the Meridian current file.
Oh, so good. So your file, your numbering is like like, because your historical 101, I think it's based, like, when we ran an example like that, we got files that were like 001, 002 for the years. Does this figure out, how does it figure out that it's gonna be 2000 to 2004? That information isn't in the standard up. Since, or,
I believe that's I think that might be in the results of NC dump. So I do most of the post-processing, so someone correct me here if I'm wrong, but I believe the 0101 means it's taken from year 101 from the PI control. So you need to look at NC dump, the results of that to check what the years are.
to figure it, okay,
Yeah.
but Zippy must be doing that automatically, is it? Because you're telling it to do 2000 to 2004.
It's in the file name as well.
I can give a little explanation for this timing. So the one, for example, we say historical 101, we want to run multiple member ensemble for historical simulation. And historical simulation starting from pre-industry control. Pre-industry control, the year, let's use like say year, from year one format. And we use the year 101 to start the simulation. The simulation was starting from like say 1850 to all the way 2014. And so that simulation will have the year corresponding to this kind of regular calendar year. And we'll have the one for year 2000. Then starting from that year 2000, then we have 10 years, 2010 or 2000, 2001 until then. So for this simulation, this is the whole extended one, include the year, matching this each segment of the year.
Does that help?
Yeah.
Okay. We can talk more in the problem set section too. So going on, so global time series, this is going to display the 8 standard plots, and then ILAM is another diagnostic tool. So I've set up a section for that. So with that, let's return to the demo, if I can find my way back there. All right, so now that we've looked through the configuration file, everything's in there. So all we need to do is run zippy-c on the configuration file. That's it. That's the command. And this will produce all the output of the jobs that it's running. So first, it's going to tell you where to go for help. If you need help, I will tell you the configuration file validated, hopefully. And it's going to run the Climo jobs. So we can see that we've generated 6 Climo jobs. We also print the environment command. So as I mentioned, you can run Zippy in whatever environment you want, but it's really important to know which environment you're running in. Just because you're running Zippy in the unified environment doesn't mean you're running the packages in the unified environment. So you want to know what environment you're running those in. Here we actually are running it in the unified environment, but that's not always the case. Also, this number here is the job ID of the batch job. So that's useful if you want to look up that. So for time series, you can see that that should be 10 jobs launched. Sorry about that. I made some changes. And then you also notice that we print E3SM to CMIP environment commands. So that's for the commands that use E3SM to CMIP. If it's empty, that means it's going to use the same environment that NCO is using. So for, in this case, the load latest, but you can actually use a different environment for E3SM to CMIP. So the reason that's a little bit more complicated is that the time series package or task uses 2 packages, right? There's NCO and E3SM to CMIP. So that gives us the functionality to run them in different environments. But by default, they'll both run on the same, in this case, the unified. So you can see that we're launching the 10 jobs. We get the IDs of all of them. They're all named accordingly to task, subtask, years. And then going on, we have the visual output. For anything that produces visual output, we print the URL too. So this is really nice. You can just go here and that will go show you exactly what where the visual output is. So we've done that for E3SM tags, MPAS analysis, global time series, and ILAM. So now all these batch jobs are will launch. To keep track of what's running, you might want to set up an alias for the SQ command. So I've set up this one as follows. There's a few abbreviations to notice. And note that it can take a while for some of these jobs to run. The Climo and time series run pretty quickly, but a lot of the diagnostic tools take a little bit longer. So this is really useful to keep track of what jobs are still running. So this is the example of what the SQ output looked like for me after I launched these jobs. So all these jobs are in the queue. And at this point, Zippy's done. Zippy has finished, but it has launched all these jobs to run. So usually we refer to Zippy being done once all these jobs finish, because that's what we actually care about, right? Like actually having the output of all of these. But that takes a variable amount of time. You got to get nodes for all these jobs. They need to have runtime. But once they're all done, you can CD into the output directory. Zippy puts everything in this post directory, and that has output for the components, and there's also an analysis directory. But probably most interesting is the scripts directory. That's where most of Zippy's output lives. And in there's 4 types of files. The status file, which tells you, did it work? So there's a few different cases that could be there. The .o file is the output. It's the log you want to look at, so that's really useful if you're trying to debug why something didn't work. The .settings file is sort of an extension of what I was saying about the environment commands printing, is that has everything listed. So it might be difficult to tell exactly how you set every single parameter in Zippy. But the .settings file is for each job. There's a .settings file that you can look at to see how every parameter was set. So it might be the case that, why is this happening? And it turns out that you just set a parameter wrong. So that's a really useful place to check. And then also the .bash files are the bash files that Zippy generated. So this is the actual scripts that Zippy's submitted to Slurm. And you can actually modify these manually and run them yourself if you're having an issue. So you can run the sbatch command. But hopefully you don't have to do that. Hopefully everything worked out. And then you can run grep-b-OK, which gives you all the status files that weren't OK. So you want to, hopefully that's empty and all of your output is there successfully. So if that works, then you know that the climatology is finished, the time series finished. And then for visual output, you can look at that. So again, remember the visual outputs at the web server path that's linked to the www. So for me, that connects here. So it shows up like this for nurse. The extended output, we have all 4 diagnostics here. Let's look at E3SM diags. So notice there's 2 here, right? There's 2000 to 2001 and 2002 to 2003. And then the viewer has everything. Look, it's all the sets we asked for. We can click on one of them, look at the annual precipitation. Here's the model and then the observation and the difference between them. Again, you should be able to access these links through the PowerPoint slides that are on the public agenda so you can view all this output yourself. So please feel free to look at that. And then I am quickly running out of time, so let me head over to Zstash.
Today's visual output pages stay indefinitely, or they get purged.
Well, they're only, I don't know the purge policy on the website, but I haven't had an issue. I guess if the data, if they do like purge the system, they tell you what subdirectories are being purged. Yeah, you should get notice about that before your stuff's just wiped. Yeah. Okay, I'm gonna see if I can switch to the Zstash demo here. Oh, this one's shorter, don't worry. Okay, so again, we're familiar with the unified environment. To run Zstash, you want to make sure you have access to HPSS. So hopefully you all have access to the HSI command. If you can log into HSI at the command line, that means that you'll have access. And what we're going to do is we're going to create an archive and then run the different Zstash commands on it. We'll do each of these in a different subdirectory to sort of simulate being like a different user coming in from a different angle. So first we want to create, so this is just, I tried to make the markdown as hand-holdy as possible. So this is just the directories to create. And then we're going to run the create command, and I'm going to highlight several different command line options here. First is the HPSS command. That tells us where on HPSS do we want to store this. So we're going to store it in this tutorial archive. Oh goodness. Okay. Let's see if I can scroll on here. And then the cache is, remember we said zstash creates the tars locally before archiving. And if you recall, we don't have write permissions to that directory. So we can create the cache to cache locally in the directory we do have access to. So we're going to be archiving the simulation that's in another directory. We'll cache locally before sending to HPSS. And then also what's useful here is the include command. Often you're probably going to want to include everything, but that's not always the case. For us, I wanted a short example, so I just wanted to include like 3 files. So I'm including October, November, December of 2000, and I can do that with this include command and this regex. The final input.
All right, I have a
Yeah.
simple
Yeah,
quick
yeah,
question.
yeah.
When you say for the HPPS argument included as none, is that quotes none or just leave it empty?
I think either will work.
Either or. Okay.
Yes, that's actually a problem in the problem set, so you can play with it. Okay. Let's see if I can get back for okay, and then so yeah, the last thing in the command is the actual directory you want to archive. And then it may be helpful to pipe output to a log, for example, with the T command. Just make sure to not archive, put your log file in the directory you're archiving, because then zstash is going to be trying to archive something that's being actively written to, and that can cause issues down the road. So just be aware of that. And then the output of this command, you can see we've archived the 3 files, right? I have not learned yet. October, November, December for 2000. So those are the only ones that were archived. We've created tar files and we've transferred them to HPSS. Importantly, the directory structure, we now have an index database in the work directory. So this is our cache. And then on HPSS, so this is on the HSI command, we now have the tar file and the index.db. And then I'm just going to run through these really quick. So check is to verify that zstash was successful. So we just give it the HPSS, and then it's checked all of them, and it says no failures detected. So we know that the command was successful. And that doesn't actually doesn't impact anything on the HPSS side, right? Everything's still there. We've just learned more information about it. And then very similar with LS, we just want to list the contents. So here we see the 3 files that we tried to archive. And again, no real change in the HPSS. Probably the most interesting thing is extract, right? So if you're trying to extract someone else's simulation that's on HPSS, how can we do that? So you just set extract, you set HPSS to the command, the archive you're trying to get. It will transfer those files, extract these 3, tell you there were no failures. So that's again the checksum checking. The verification there. But now we have the archive directory that we were after. Archive/atmosphere/history has the 3 files that we archived originally. So we have successfully extracted those. And again, this doesn't actually change what's on the HPSS side, right? We have just accessed it and copied that down. Okay, so I've actually made it through the demos, only marginally over time. Yes.
So when you archive, it doesn't remove anything from your working directory, right? You have to, once you've checked it's archived, you can go ahead and delete things, but it's not deleting anything.
Yeah,
For you, okay.
that's correct. Yeah.
For the extract,
Mhm.
and that's supposed to be the entire archive. Can you, I mean, as you listed, can you inquire and extract specific files or say, I just want the atmosphere output out of this archive? Can you extract?
Oh yeah, that's what we did with the include command. So we specifically said we only want to include 3 files.
but
Oh, I see, I see.
I see in the extract.
Yes, you can also do that.
Oh, okay.
Yes, yeah. Sorry, yeah.
Yeah.
A
Thank you.
lot of the command line options are throughout all the
I see,
options,
sure.
yeah. Okay, are there any other questions before we dive into the problem sets and then you can sort of play with it yourself? Okay, so you should all have access to the problem sets. I'm just gonna briefly introduce them here if I can. So one is the Z-stash problem set, which is linked in the slides. It's the last slide or second to last. Make sure to look at the documentation and discussion page. For both SIPI and Z-stash, the way I've set this up is I have use cases and debugging scenarios. They have hints and solutions. There's roughly 10 problems total. So maybe spend like 5 minutes per. I would try to solve the problems before looking at the hints and solutions. Really try to see if you can look at the documentation and the discussion pages, because this is going to be your experience as a user of these tools, right? Being able to find more information and knowing where to ask for more information if need be. So the discussion pages are really useful for that. So yeah, try going through these. Let me see if I can pull it. For the Zippy, what I've done is created sort of a bridge configuration files that sort of highlight the relevant parameters. But if you can figure out what like the bridge configuration file should be, you have extra time, try to create like the actual configuration file to see if you can actually get it to run these problems with the nurse reservation we have today. So that's sort of the extra credit task. Yeah, thank you.
Thank you.
A number of you, make sure you uncomment account and reservation in the configuration file if you're trying to run it. Also, I would suggest working through the problem set first by hand and sort of working with the abridged files. And then if you're really feeling into it, try running what I did for the demo. You can either run wget on the file from GitHub. You can clone the Git repo. You can just copy it directly from GitHub and try running it yourself. So this is the case where you need to change the account and reservation. You may need to change nodes. I've heard that you only have a 2-node limit, so be aware of that. So there might be a few things you need to change if you're actually trying to run these configuration files. But again, I'd recommend first starting with the problem sets that give you hints and solutions, and those direct you like which abridged configuration files to look at. Okay, I think those are all my reminders.
All right, so I think we'll start off with this one. Everyone's been successful in submitting jobs because right now we're fully utilizing the reservation. But that also means that if we have the whole reservation being used, we can't run the test for the next case. Yeah, so
We can do an exercise.
so first off,
Who can get the job removed from this list quicker?
and so this is the list of jobs that are currently running it on ours. And so you can see the ones that are running. So this is a way that these are waiting, and there's a long list of jobs that are waiting. And so the request is first, you can check what kind of jobs are running. So I don't know, let's see if I can make this bigger. I think we brought this up a couple times, but just as a review, you can check what job, what your jobs, right now I'm not running any jobs, but if you do SQ-U and then your username, you can see what jobs are running. And to cancel your jobs, I know it's painful to cancel your jobs, but if you want to run the next one, it's a group effort to cancel, and you do cancel. And then under job ID, you'll see your number. So for example, this, and only you can cancel your own jobs. We can't cancel your jobs for you. So
you're asking.
we're asking you to cancel your jobs.
Cancel all of your jobs, or you have to do it individually?
You can do -u username after cancel.
S cancel -u.
Thank you for that. Yeah, I've never done that, so. And so, let's see if, interactively, we can start to see how I think we're slowly reducing the numbers. But you can work on that right now, but, the first,
So the first part, so today's running your simulation practicum's gonna be about modifying the source code. So you'll hear from me, from Wuyin, Mark and Darren, Darren, as well as Dan. And so we'll all go through one example, doing just writing something in the log file, making a small change in your source code, having it write something in the log file, and then you'll have the option of doing something in the atmosphere, in the land, or the ocean sea ice, and we'll go through all of them individually. And so in order to make changes, so that's kind of what I talked about, but the steps that we'll do today is first create a new branch off of the master branch, and so we'll be using the branch that you've cloned into your local directory. Then we'll make a small change in the code, and then just in terms of familiarity with Git, can I see a show of hands of people who are familiar with Git? So about half the people, so a mix of experiences. So for you who have experience with Git, this will be review. We'll do Git add the file that you've changed, Git commit the change, and this is a way that you can have provenance about the changes that you make. As you're making many changes, it's always easy to lose track of what changes you've made. At least with Git, you can actually keep track of what the changes were. And the simulations, you can actually look up what the Git hash was used, and based on that, you can look back on what code was used to run your simulation. And then at the end, we'll run a simulation based on modified code, and that's where I needed your help to clear out the reservation nodes so that we can run these test simulations. So let's go find your E3SM code that you've locally cloned. And so if I can ask everyone to just go CD, for me, it's in my home directory under E3SM underscore code and then master. And if you do ls, you should see something along those lines. So I'll give everyone just a little bit of time to get to there. And the step 2 is verify that you're on master. So if you do git space branch and you hit enter, you should see master highlighted with an asterisk next to master. So everyone's been able to modify, and if you're taking time, the slides are all up on the agenda as well. And so if you lose track of where we are, you can always just refer to that. Now let's make a new branch. You can make a new branch by using this command git checkout -b, and then you don't have to call it hello world branch. You can call it whatever branch you want to call it. And by doing so, what it does is it creates a new branch, and then it checks it out. So you don't have to, there's other ways of creating a new branch, but this way you're automatically on to the new branch that you've just created. And you should see something along the lines of you've switched to a new branch with your branch name. It's always good to verify that you're on the new branch, because I've often made new branches and then assumed that I was working on it and then realized I was still on master. So it's git, if you do git space branch and you hit enter, you see next to the new branch name, hello world branch. You should see an asterisk next to the new branch that you made. And you made a new branch. So I think it's time to start making changes. So the change that there's gonna be 2 ways that you can make these changes. One is to actually go down from your code. So now I've actually CD'd down from, we started off with master. If you go back when you were on master, what I've done next is CD down to driver MC into the driver code, and then one more directory down to main. And then if you do list, you should see these files in there. And so there's 2 different ways to modify the code. Usually you wouldn't be copying because you wouldn't know what changes you're gonna be making, but we've also made it so that it's easy if you didn't want to go into the code with GI or for me Emacs and then make the changes. The second way is we've actually Wuyin's created the file that you want to change, which is the seam driver F90 file, and then you can just copy that over and into locally. And let's see. Right. Yeah. Oh, what are the changes? Yeah, that's.
What line number should we be adding this to?
You should go, you can actually see it. So right here, so if you go down to line, I think 6, no, it says 58. I think 60, line 60 is what I thought. I can double check too, but it should be around line 60 and it should, if you look in the code, it should have set up and initialize the communications and logging. It's the first thing, Wuyin was able to find the first thing, right? First thing that's run.
Yeah, the first code being executed by this big model.
Yeah, and so we're just adding a print statement at the very beginning. And then the line that you want to add, you can ignore the plus signs, but just these lines. But just in the interest, if you're fine with just copying a file and trusting it, well, there's ways of testing it, but you can just copy this file that Wuyin's just uploaded here into this directory, just copy it into your local directory. And the way to check whether it's actually done what you want, so you then you can run git diff. And once you run git diff, it'll show you what the differences are in your local branch or local file.
So we want the git diff in the same line with the CPG.
After it's the next line.
Okay.
You don't see anything, no change? Oh, there it is. Oh, yeah. Yeah, it might take a second for it to work out. Maybe I'll pause here and raise your hands if you have if you need help, because I think this just being able to. I forgot to mention, you don't have to use Emacs, but this is my text editor. This, you can use VI and edit Nano, whatever editor that you want. Maybe we can, in the interest of time, we can move on and then you can review the slides and I'm happy to help out the people who are still working. Is that okay? Yeah.
Move ahead.
Yeah, we'll move ahead and then, so the next steps after once you're there is you want to git add the file and then git commit -m, and it's always good to put in a message, a commit message that makes sense. In this case, I was adding a hello world message in the log file under, maybe I could have added that it's in the driver and see, which file it was, but it gives at least some provenance about what the change was. And so you can also just copy and paste these lines.
What is the ad doing before you commit?
It specifies which files you want to add
Oh,
to
so you
this.
can put multiple
Yeah.
ones in
So
there.
you can add multiple files, for
see.
example, yeah. If you're making changes across multiple files, it can be in one of it.
I always, okay.
But you don't want to make a commitment manually, yeah, otherwise it's useless, yeah, it doesn't helpful, yeah.
So then, yeah, so just enter the message and close out of the editor. Whatever you want it to be.
All right,
You don't need the.
did I move a little too quickly? Yeah. Yeah. And then once you do git commit, usually you do get this, it'll tell you how many files were changed, insertions as well as deletions, and that's usually tells you, at least gives you a sense of what the changes were, and you can always check later.
So is this the?
Branching change.
And then now it's all about running the simulation. And so Wuyin has, so if you have your next step, once you've made your code modification, that's all you need to do. Then you go to your run scripts where you've been keeping all your run scripts. For me, it's under the home directory, under E3SM run scripts. It might be different for you. So, and then you copy this particular run script that Wuyin's made for this particular, it's for this particular tutorial, practicum session. So it'll include the reservation for today as well, and so forth. And the only modification I think that you need to make is to populate your code root. And code root needs to be then where your code resides. So this one, yeah, you can.
Previously, we used a script without the run, just the E3SM script, but no harm if you create another directory, no harm.
It wasn't E3SM scripts.
Doesn't matter, if you create a new one, just stay with the new one.
And so once you open up your run script, you'll see if you search for code underscore root, it'll be empty. And that's where you want to populate in double quotes, in between double quotes, where your code resides, the E3SM code.
It appears that yes.
Yeah.
Where is that? One level above the master branch.
I would say, so I would say for our case right here, it'll be global. So once you get to, I'd say one level under, so in the master branch. So I would include everything up to master.
Up to and including master.
Yeah, up to and including master. It'll be the directory where if you do ls, you see this whole. And then one way, if you might need the whole, instead of tilde, you might need the whole thing. So type in pwd, that'll give you the whole, the actual, for you, what it is. Oh, yeah. It should be just about the case root to change. Case root doesn't need to change. And it's going to be a different case name from before, so you won't be overwriting anything. Yeah. And if you've already made that change, you can just run that script. And it should start, yeah, like case, setting up the case, building nameless, building the code, submitting the simulation. It should be a 2-node job, and it should be quite quick because it's only going to run 3 model hours. And all the changes you'll see later.
For the top level.
So I'll keep this open. Code, something it talks about the ELMs. It's likely that you're building while on the E3SM unified environment. And so you want to make sure you remove the open up a new terminal and then build your case.
Or do content deactivate.
Or content deactivate. That's another.
Why is that? Why is it not?
That's something we should work on, but it's right now it's this odd, something about the environment doesn't code first, I guess. With building. So I've been tripped up with this.
I remember hitting that error first time.
Able to submit or do the SH on the run script? Raise your hand. Did you get through the previous example? And probably we just looked at the queue. It looks like half of your jobs are running and half of your jobs are waiting. So while that happens, I have an example code change for the ocean. And the ocean and the sea ice are both MPass components, and they both use MPass framework. So they're quite similar. So we're just going to do an ocean example. for those two. This is under the agenda. It's as a separate, just a 3-page PowerPoint. So you can download that. And even if the ocean isn't your main component, it's just a copy and paste exercise. So I think everyone can do it. And then we're going to do the land here in a few minutes. And so something that's nice to browse through, if you go back to your code repository at the top level, and you CD into the components directory, and then LS, you'll see all the different components we've been talking about this week. And so in that, you'll see MPass Ocean, MPass Sea Ice, and all the others. And then all of those individual components have their code within, and I think they can all be compiled as standalone models as well. We're not talking about that this week, but if you're actually doing code development for your project, you may want to look into that and look into the documentation or talk to people about that. Because sometimes it's easier to do code development in standalone mode to begin with. But today we're doing E3SM. And so this is the file that I'd like you to edit. And this is in the ocean, it's actually the main time stepping loop. And so if you can go to that file, and the line right here is ocean time step, and we have numerous time stepping methods. So that calls the appropriate time stepping method that you've chosen with your config file. And then there's other modules for every single term in all the equations that we showed. But for right now, we're just going to put a couple different types of print statements there. And so in MPass, there's a log writing system, but you can also use an old-fashioned Fortran print or write statement. And I have both of them there. So you can grab these little lines of code and you can replace it with your name. And what I want you to see after you run it is that the log system goes to the ocean log file, and anything that you just do an old-fashioned Fortran write or print statement, it goes through to the E3SM log file. So you can still do what I call old-fashioned debugging, right? Sometimes you ask the question, if I'm changing the code here, am I here? Is this running? What do my variables look like? And so you can still do that, but it doesn't come to your screen, which is actually better because you're submitting jobs to a queue. All of that output goes to, if you just do a print or write statement, it goes to E3SM log. And the other thing is that I believe we're running 2 node jobs right now. And how many cores per node do we have? 120? What, 28? So there's 256 if you're running on 2 nodes. So the logging system in MPass only writes 1 message for convenience. But if you're doing debugging and you want to know what different processes are doing, if you write it the second way with a print statement, it will actually write a message from every single processor. So I have both of those examples, and you can just copy and paste those in. You can do this in the code repository that you just changed, by the way. Then it'll just have multiple print statements. And then you can do, I didn't put those instructions here again, but what Chris just told you. So you modify your code, git add that file, git commit, and then if you use the same, you can use the same run script, but you want to give it a different, what's the name of a case name, a different case name, you could just put a number at the end of it or something. Otherwise, if you do your SH on the run script, it'll tell you that directory is already populated. Huh?
Do we need to use the same indentation for those lines we're pasting?
No. Fortran doesn't care.
Okay.
Just fine.
This goes in that do while.
So if you find the ocean time step, you can put it anywhere right around there. Yes, it's in the do while. And that's the time stepping code. And so I'm just going to talk about example number 1. I have another example here that's actually in the pressure gradient code. And again, it's just a copy and paste. So for those of you that are going a little faster, you can try that as well. And if you just want to look at it, I just have some examples here. You know, there's some variables in an actual term that you're computing, and you want to print some values. That's just an example of that. And that's a very typical thing that you'd like to do. So why don't we let you guys work on that for 5 or 10 minutes, and we'll walk around.
Okay, can you just search?
Okay. I really did test this morning. So Wuyin just pointed out that this character right here, PowerPoint changed it to a different kind of a quote.
That's happening. But if you check the log file, you see which line, which one they terminate character constant. So we do code change, open which one is that one. Another opportunity.
So when, of course, this was an exercise in debugging. So if you look at where when it's building and then it has an error, the very last thing it says is look at the build log file. And you can look at the build log file, and sometimes it's hard to figure out what went wrong. You usually hope it's at the end, but not always. But in this case, it should point to that log, the compiler.
All the way to the end, and in fact, error.
So should that be error?
The other word.
Okay, so what you can do, if you go back to your code and change that, it's after the word processor. It should be a single quote from your keyboard. And then if you delete that base directory, then you can just, you can do bash or sh on your run script again. The log files, it's always in the case directory. And then I think it's in scripts or no, each directory has its own log files. So I think in build, there's log directories, log files.
Not to add too much more work, but we have a lands code edition as well, which is pretty similar. Yeah, and we're not gonna go through this live, so if folks want to look at this later, it's pretty similar to the first example. And we're just gonna make a change where we print out some variables each time step at a specific grid cell. So we can grab this ecosystem balance check routine, put that into your repository, get diff. And so what it's doing is basically what's normally done is a balance check. So it looks at the carbon coming in and out of the grid cell, compares the flux variables with the state variables, and if there's something off, it crashes. So I'm just modifying that to print out all these terms, regardless of whether or not there's an error at a specific location. The default location that I put in there is the one grid cell nearest to where we are right now, but you can go in there and you can change it if you want to whatever lat lon that you want. So the land grid is running a 1/2 degree resolution. Grid cell centers are on the kind of the 1/4 degree there, so you can change those ranges as you want. Sort of follow the example from before, copy the run script, change, presumably we've already done that with the code root, change the case name to something else, maybe dash land at the end so it's not interfering with the previous cases that you run, and then go ahead and run the case. And then you'll see, if everything goes well, in the E3SM log file, you'll see this for, I think, 6 time steps. So the variables there explains the time step, the column balance, which is the input minus the output, which we hope is something close to 0.
These 4 line copy.
The lat lines, inputs and outputs, and then I've kind of left comments here as to what each variable means. You won't see that in the output. You can refer back to this, see what the specific variables are. So things like ecosystem respiration, loss of carbon from fire, harvest, things that are leached out of the column. So these units, if these units are grams carbon, to give you a sense of how much carbon is in the grid cell. If you play around with different locations, you'll see the different numbers. And then how much is changing in this half an hour time step, which is generally pretty small relative to the total.
Does it print out this whole chunk anyway, or we're gonna add this whole?
It will not unless,
It normally doesn't have any.
only if you change the
Okay.
code. So normally it would only print this stuff out if there's a problem, right? So if there's a balance error, it'll tell you where it happened. But oftentimes when we're running the model, that's like the end state of a problem that began way before that. So if you wanted to print out, for a long time, you could do it this way.
So then you some variable.
Yeah, just let me know if you have any questions with this one later on. Do it tonight or tomorrow.
Okay, well, while I have your attention, maybe I do want to take the poll since tomorrow's practicum. I know everyone's been working hard and there's a lot of problem sets to solve, and many of you might not have been able to finish all of the ones that you wanted to finish. And so tomorrow we have breakout practicums. There's one on the atmosphere, there's one on the land, and there's going to be one on the ocean. But there's also the option that you're welcome to just continue finishing up and asking questions from the TAs as well. And so what we wanted to do was to get a sense of numbers of interest, so that with some of the breakout rooms, we'll have them in other rooms just so that everyone's not trying to talk over each other. And so can I get a show of hands of people who want to continue running the simulations that you'd like to, that you've been running so far for tomorrow's practicum session?
What are we doing in the new one?
The new ones, okay, so for the, since I think we have Walter, yeah, sales pitch from everyone.
On my slides, I can't show you, but the one we're doing tomorrow, it's all gonna be all about running a hindcast and creating initial conditions. So I've set everything up, so it's a lot of just copy and paste, but you'll be creating your own initial condition, and each person will be perturbed differently. And so then you'll run that, and then hopefully if everything works well, I'll plot them all, and there's a hurricane in the initial condition, and we'll see a cone of uncertainty.
That's a good sales pitch.
Yeah. All right, so for the people interested in ocean and sea ice, we'll take a tour of the code and try and connect some of the pieces. So during my talk and Alice's talk and Darren's talk, we talked about the model equations and the stencils, and we wanted to show you where those actually are in the code so you can put that together. And then practice some visualizations. So when you have your output, so we're doing print statements here, but to actually see what you're doing, you need to see some fields, typically 2D fields from NetCDF files. And so we'll show you how we typically visualize those, and we'll do a little practice on that.
For land, we'll focus primarily on the I cases, so these are offline land simulations. I think people are interested in single grid cell simulations, and so if you want to run at a single point, we have a framework that can simplify these two stages of spin up and transient into one command. So hopefully, and it's pretty fast. So it's just one grid cell. Hopefully you can run long enough to actually see what a spin up should look like. We can also experiment with some regional simulations, setting up global runs. So we can be flexible for whatever people are interested in.
That was a good question. And so everyone's got a little bit of a trailer of what you might expect in each session. And so I guess we can start off with atmosphere. Can I get a show of just hands? How many people might be interested in running the atmosphere? Okay. And then the ocean. And then land. That covers a lot of people. People who would.
Anybody raise more than once? Make sure you can with your.
Yeah, the material's gonna be available, so you can always run them after the fact, but it's always nice to have it in person. And then people who want to continue doing their what they've been running. Everyone wants to try something new. Okay, great. That gives us a bit of sense. I think, given the numbers, the atmosphere will be in here. And then tomorrow morning, we'll let you know with the ocean and land, which rooms to go to run those practicums. Okay.
And then we have the node still reserved. If you want to continue the simulation, just like yesterday happens tonight for that will be on the agenda page. The content is the same as yesterday, just make sure you change to the, how to quit this one. Yeah, it's on the agenda on this night. This was day 3. So basically you can do whatever non-simulation plan to do. And then also today's experiment, you want to continue to run it. Just make sure you change to the reservation day 3. And then the other one, just say, still one example. If you want to resubmit or continue to run, you can use this format. The node will still be reserved until midnight.
For tomorrow, so we're done for today, unless you wanted to take the tour. Please remember to bring your stuff. We'll meet again. 8 o'clock is breakfast, and then 8:30 will be started the sessions again.
If you're doing the tours, please leave your backpack.
Oh.
Okay.
Take 2 group pictures. It's not allowed.